Hi everyone, today we're going to be going over an example about integrating the area between two curves, and for today the two curves are a quadratic function f of x and a linear function g of x. And before we start, we just want to go over the steps required to solving a question like this fully. So we just expect you to find the area between the two curves. So the first step is we have to draw the curves on the same axis, and that's very important because if you draw them on different axes or planes, it's going to be a bit difficult for you to see which area we are talking about, which area is between these two curves. So drawing them on the same axis or the same plane will make it more easier to see which area the question is asking about. And the second step is finding the boundary. So for this integration, it's a sort of definite integral we have to make. So we're gonna need the ranges upper and lower, and for that we have to find the bounds. We're gonna have to equate f of x with g of x to find out what are the intersection points, or basically the points of intersection. And the third part is just gonna have to do the rigorous integration to find the area that we've been asked to, and that's after we've discovered what this area looks like and what are its limits. So let's get underway. Okay, so I'm gonna be using a blue pen. So solution. Okay, let's start with step one. We're gonna have to draw this curve. So our function f of x was given as 3x squared plus x plus 1. Okay, and g of x is equals to 3 minus 4x. Okay, that should be easy to spot out. So the first part is we have to draw this curve. So I'm just going to create an axis for us to work with. I will be skipping some parts here because this is a very lengthy question. There are parts which I assume you can be able to answer yourselves. You can be able to solve yourself. Like for now, for these two functions, I expect you to be able to at least draw them on your own. I will outline the ways in which we find these lengths. We find the shapes of these curves. For starters, our f of x, I'm just gonna use a red one now. Our f of x is a positive quadratic function because the coefficient of x squared is positive and 3. So to find the turning point, you just have to find the derivative of f of x and make it equals to 0 to get where x tends. And for this specific question, the turning point is at, and it's going to be at a point here, which is what is it, minus 1 over 6, 11 over 12. So that's very important. So you just have to know. So it looks something like this. So I don't think I actually need to specify that point, but you just have to know it's a positive function and it doesn't go across the x-axis. It just the only axis it intersects is the y-axis, and it intersects it at a point we're not really interested in for this question. So I'm just going to draw it like that, and that's going to be our f of x. I'm just going to point out that's our f of x. And then for our g of x, is a straight negative line. Because the coefficient of x here is negative, it tells us it's going to be slanting to the left, and it's basically a negative straight line with a negative gradient, and it passes the y-axis at 3. So we're just going to have 3 somewhere here. It's going to be at 3, and it goes down like that. So that's not really to scale. Let me change that. Yeah, so you should somewhat get an idea of what it looks like, and this is our g of x. and then it hits this point at 3/4. Again, not so much to scale. So seeing from this, our point of interest is, our area of interest is this area here, because this is the point which is bounded between these two curves. Okay, so the next step is we have to find the bounds of integration. So this simply just means we have to find that point here and that point there, and the only way to find that point here, I'm just gonna label it, because this is gonna give us our boundary of integration with respect to x. So I'm just gonna write this as number 2. And like I said, to find those 2 points, we have to say f of x is equals to g of x. Now f of x again is equals to 3x squared plus x plus 1 is equals to 3 minus 4x, and this is g of x. And then if we move this to the left, we're going to be left with a simplified function of 3x squared plus 5x minus 2. And in your spare time, you can factorize this. If we factorize, I'm just going to skip a few steps. We're going to find that this factorizes to 3x minus 1 multiplied by x plus 2, and this gives us our boundary points, where x is going to be equals to a third, sorry about that, and x is also equals to minus 2. Okay, so now we have our 2 boundary points, which are going to be essential for integration. And the next step, I'm just going to make a new page. Let me just quickly go over here. We're going to have to integrate to find the area. So I'm just going to open a new page. We're going to integrate to find this area. And this is going to be our last and final step. Okay, we've already gone 7 minutes. Okay, so let me undo that. I want to use a red pen. Okay, so for areas that are enclosed by 2 curves, the equation says that the area is the integral, draw that better, from x0 to x1 of the top function minus the bottom function with respect to x. Let me just put that in brackets. Okay, so our top function from this diagram is our g of x, the straight line, because it's above our curve at that point, our quadratic curve. So we're gonna follow this expression and we're gonna see where it takes us. Our x1 and x0 is minus 2 from the previous step, and our x1 is a third. Okay, so I'm going to switch back to blue. I think that will do nicely. I'm going to use a smaller inking. Okay, so I'm just going to put brackets there, and we're going to have 3 minus 4x, and that's our g of x. I'm going to label that a bit when I'm done with this. 3x squared plus x plus 1, and it's going to be d of x. And then I'm just going to point out what this is. This should have been out. This is our g of x. This is the top one, and this is our f of x, our quadratic, which was on the bottom below our g of x, between the boundaries minus 2 and the third. Okay, so before we do any more integration, I think I'm just gonna simplify what's inside the bracket. So minus 2, yeah, I think that's an improvement in the writing. Okay, so I'm just gonna simplify what's in here before we do any more integration. before we do any integration. 3x squared. Okay, we're going to have minus 5x and minus 1 and plus 2. Yeah, should be plus 2 dx. And if you do the integration here, we're going to be left with this. We're going to have minus, oh sorry about that, I'm doing something completely different, minus 3x cubed all over 3 minus 5x squared all over 2 plus 2x. So we don't have to include the constant of integration because they cancel out since we're doing a definite integral. Minus 2 over 13. So all that's left is to do substitution, and if you do it correctly, you should get 343 over 54. And then you can also write that down as 6 and 19 over 54 if you want to write it as a mixed fraction. And that should be your area. I hope that was very helpful. Until next time.